Hi guys, this is Miss Lemons, and today we are going to be doing some practice problems with bond energies, or bond enthalpies. Okay, so we're going to use our chart of bond energies. That is a resource that's been provided to you. We're going to use our chart of bond energies to calculate the delta H for the reaction below, and this is the question number 1 on your homework. So we've got 2 H2O yields 2 diatomic hydrogen plus 1 mole of diatomic oxygen. Okay, so let's take a look at all of the different bonds that are going to be broken in our reactants. So you can see here that these are all the same type of bond. We have an HO bond, an HO bond, another HO bond, and another HO bond. So that counts for 2 waters, and we happen to have the same type of bond 4 times, right? That HO bond. That OH bond, we have 4 of them. The value of it on our table is 464 kilojoules per mole. Okay, so for every mole or every bond, it's 464 kilojoules. We happen to have 4 bonds, so we would multiply that value by 4 to get the total amount of energy that is required to break those bonds, which gives us a total of 1,856 kilojoules. Okay, so if you look for our bonds that have been formed, our products, we've got an HH bond, and we've got 2 of them, right? And then we also have 1 double bond between 2 oxygens. Okay, so the values for those on our table are 432 kilojoules and 494 kilojoules. And that's how much energy is required to break those bonds. We're going to go ahead and multiply each of those values by the number of moles of each, and then add the totals together to get us 1,358 kilojoules. The last step is going to be taking this and plugging it into the equation that we were provided, which is bonds broken minus bonds formed. So we're going to take the number of bonds broken, which was or the amount, the enthalpy of the bonds broken, and that's 1,856 kilojoules, minus the sum of the enthalpies of bonds formed, so that's 1,358 kilojoules, which gives us a total of 498 kilojoules per mole. And because it's a positive value, right, that sign of delta H, or enthalpy, is going to show us the direction of heat. So if it's positive, we are gaining heat. Therefore, this is an endothermic reaction. Okay, so let's go ahead and take a look at bond energies for number 2. Use bond energies to calculate delta H, or change in enthalpy, for the reaction below. Okay, so just so you guys know, on your test, you will also be given the structural formulas. You do not need to draw Lewis-Dot structures or structural formulas for this test. We've already done that. So just focus on the pictures that have been provided for you, or the structural images that have been provided for you. So CH4 plus Cl2 yields CH3Cl and HCl. So this is actually the example I showed in the, similar to the example I showed in the conceptual video, but let's pay attention to the different types of bonds that we're looking at. So you'll see on the molecule, the far left here, CH4, we only have CH bonds, CH bond, right? This is a Cl bond. So we've got 1, 2, 3, 4 CH bonds and 1 Cl bond. These are 2 different types of bonds. I'm going to take a look at my chart, my bond enthalpy chart, to see what the value of those bonds are. So for one CH bond, it's 411 kilojoules per mole of energy that is required to break or make that bond. And then for a Cl bond, that's 243 kilojoules of energy per mole. And because we have 4 CH bonds, multiply that value by 4, add those 2 values together, and we end up with 1,887 kilojoules for our bonds broken. Looking at our products, now we are forming these bonds. So we have a CH bond, a CH bond, and a CH bond. So I've got 3 different CH bonds, and you'll notice that I also color-coded it so that we could see that this CL bond is in fact different than that CH bond. So we're using a different value here. We also have an HCl bond, which is a different value from the other 2 that we have. So we only have 1 of the HCl's, 1 CCl, and then 3 CHs. We would then plug the values in from our table, our bond energies table. So for CH bond, it's 411. For CCl bond, it's 327. And for HCl, it's 431 kilojoules per mole. Multiply them by how many bonds they have each. We only have one of these on the HCl and the CCl, but 3 of the CH bonds. And then add them together to get us 1,991 kilojoules. Then we're going to go ahead and plug these values in at the bottom. The sum of the bonds broken and the sum of the bonds formed. Plug them into our bond energies equation, which is sum of bonds broken minus the sum of the bonds formed, which gives us negative 104 kilojoules of energy. And because this is a negative delta H value, we know that it's also going to be a negative delta T and a negative Q value, making this an exothermic reaction. That means that this reaction is releasing energy to the surroundings, not absorbing it, right? It's exiting, exothermic. So if you need any additional practice, I do have a few more extra practice slides on this PowerPoint. Feel free to peruse those at your leisure. I will also be posting an extra worksheet. And if you need any help, you guys know you can always reach out to me via Remind or email. Have a wonderful day, and go Warriors!